How could anti-gravity devices manipulate spacetime? Imagine a world where objects float effortlessly and space travel becomes as simple as a gentle push. While that might sound like science fiction, scientists are exploring ideas about how anti-gravity devices could actually work by changing the very fabric of spacetime. Spacetime is the four-dimensional structure that combines space and time into one. According to Albert Einstein's theory of general relativity, gravity isn't just a force pulling objects together. Instead, massive objects like planets and stars warp or curve spacetime around them. This curvature is what causes what we feel as gravity. The more massive an object, the more it bends spacetime, and that bending pulls objects toward it. Now, to create an anti-gravity effect, a device would need to do the opposite of what massive objects do. Instead of curving spacetime inward, it would have to create regions where spacetime is bent outward, or in a way that pushes objects away. This would involve generating what physicists call negative energy or negative mass, which is a concept that defies normal physics but is theorized in some advanced models. Negative energy could, in theory, cause spacetime to curve in a way that produces a repulsive force, kind of like an invisible push. One idea involves manipulating energy fields around an object. If you could fill a space with a special energy field and then create tiny bubbles within it that have less energy than the surrounding space, those bubbles might act as if they have negative mass. This negative mass could generate a repulsive effect, similar to anti-gravity. But here's the catch. The amount of energy needed to produce even a small effect is enormous, far beyond what current technology can handle. We're talking about energy levels that would requiring massive power sources and advanced containment methods. Another approach looks at black holes and spinning massive objects. When a black hole spins extremely fast, it drags spacetime around with it in a process called frame dragging. In some extreme cases, this dragging can create a sort of push away from the spinning mass. While this effect is real and predicted by Einstein's equations, it only happens near black holes or other supermassive objects, not in everyday life or with small devices. Some scientists have experimented with electromagnetic fields and superconductors. For example, spinning superconductors have shown tiny reductions in gravitational pull in laboratory tests. However, these results are inconsistent and have not been confirmed by independent experiments. Many in the scientific community remain just skeptical about these claims. In the realm of eccentric inventions, some inventors claim to have built devices that use unusual electrostatic fields or other unconventional methods to produce a force that counters gravity. These devices often claim to lift objects or create small upward thrusts. But so far, no independent tests have verified these claims, and they are generally considered pseudoscience by mainstream scientists. If someday we manage to manipulate spacetime directly, it could revolutionize transportation and space exploration. We might lift heavy objects with minimal energy or even develop faster-than-light travel. For now, these ideas are mostly cosmic curiosities and scientific oddities, inspiring both scientists and science fiction fans to think about what might be possible in the future.